Welcome Year 9. I've decided to put together a video for some of the content that you're doing in week 1. I'm going to cover the 8F area, which is factorising trinomials, and in probably a second video I'm going to cover, well, another factorising trinomials, but a little bit more complicated ones. This is new content, and it's actually content that matters a lot for what you're going to be doing in Year 10, 11, 12 mathematical methods. So yeah, probably best we have a video for this one. All right, to start with, we need to remember some old concepts. So if we had something like this, x plus 3 times x plus subtract 4, by now you should be very comfortable in expanding. What does expanding mean? Well, essentially it means getting rid of the brackets. I recommended to you that you draw the claw. Essentially everything in the first brackets had to be multiplied by everything in the second. Some people call it FOIL, you know I don't like that. And what you get from that is x times x, which is x squared, x times negative 4, remember negative belongs to what's after it, x times negative 4 is negative 4x, 3 times x is 3x, and 3 times negative 4 is negative 12. Now from there you should be able to simplify that. Those bits in the middle, like terms, you can combine them and you'll get x squared, negative 4 plus 3 is negative 1, take 12. So you should be comfortable with doing that. So importantly, when we went from here to here, we did something called expanding. Today, what we're doing, the lights are playing up with it. That's really annoying. Okay, anyway, it's expanding when you go in that direction. And when we go back in this way, we're putting in the brackets. It's called factorising. We haven't actually done factorising of things in this form before. When you've got 3 parts, that's what the tri means. Tri means the 3, right? When you've got 3 parts and you're factorising back in this direction, we haven't done this exact form before, where you've got something x squared, something x, and something on the end. So what we're going to do today, one of the first things I like to introduce is a little bit of terminology. I'm going to write a general form of these things. I'm going to write it as ax squared plus bx plus c. You're going to see this a lot more as time goes on, so we may as well learn it now. Now what that means is, for example, if I had 3x squared take away 4x plus 5, what would the value of a be? A is what's out the front of the x squared. So in this case, a would be 3, b would be whatever's out the front of the x. So b is negative 4, remembering negative belongs to what's after it. And c is what we know as the constant. It doesn't have any variables attached to it, it's just a number by itself. C, the constant, is 5. So whenever you see one of these things, you should be able to tell the values of A, B and C. You may need to rearrange them first. For example, if I gave you something like this, 5 take away 4x take away, I'll be really weird, I'll do x squared divided by 2. It's not in the standard format yet, because the bit with the x squared's over here. The bit with the x squared should be at the front. I could rewrite this whole thing as, remember the negative belongs to what's after it, be negative, and that's the other trick there, it's divided by 2. Right? Another way you can write that expression is just to call it a half, and then x squared. Next is the bit with the x in it, so it'll be negative 4x, and then plus 5, because there's no negative out the front of the 5. So in this case, it's a bit different. The a will be what's in front of the x squared, it'll be negative a half. The b is what's in front of the x, which is negative 4, and the c is 5 again. All right, that's a more complicated example. Now, let's get to the actual factorising. Maths teachers often have vibrant debates and arguments about the best way of doing this. So you're learning it a particular way, you may find other teachers do it slightly differently. The technique I'm going to be showing for factorising trinomials is called crisscross. The reason I show you this method is because it works in more complicated situations, and you guys are going to be doing the more complicated situations, so we are going to do it this way. Crisscross essentially involves drawing a table. And what we do is we write the ax squared part up here from whatever your trinomial is that you're trying to factorise. We'll start off with that one. We'll do an easier one than that first. I'm actually going to do an easier one than that first. We'll start off with this one, x squared plus 7x plus 10. So when I draw a table for this particular case, the ax squared part is this. It doesn't actually have a number in front of the x squared. The examples I'm doing this first set won't actually need that. But we write the ax squared part here. So in this case, I'd write x squared. And the other part of the table, we write the c component. In this case, the c component is 10. So in this case, I'd write 10. That's how you set up the table to start with. Now things are going to get a little bit weird. We essentially test different combinations of variables and numbers until we get one that works. And you'll see what makes this work in a moment. So to start with, we think, what can multiply together to give x squared? Now, in this case, it's not too hard. You're probably going to think x and x, right? X times x gives x squared. And every time it's just x squared, it always is just going to be x times x that we write there. Over here, on the other side, we then think, what can multiply together to give 10? There's a few different things that can multiply together to give 10. The first one, and I'm going to do this because I know it won't work, is 1 times 10. Right? 1 times 10 is 10. Now, the crisscross comes in at this point. I draw a crisscross here, and I go, what I essentially want is the solution is the combination where if you add the cross products, you get the bx component. So here, right, remember, that's our ax squared component, that's our bx component, that's our c component. The outcome of all of this is we're trying to get 7x. What we do is we multiply here, cross product. What's x times 10? That is 10x. And we add the other diagonal. So we get 10x plus 1x. And in this case, we'll get 11x. The idea is we wanted 7x, but we got 11x. This is not the solution. So what we do is we try a second solution. So I'll do that here. Again, I need to think what multiplies together to give x squared, which is just x and x. But we'll try something different to give 10. How about this time we try 5 and 2? All right, 5 and 2 multiply to give 10. We draw our crisscross together. This time, I've got x times 2, so 2x plus x times 5, which is 5x, which is 7x. I found my solution. But you're probably thinking by now, hang on, you found a solution, but it doesn't have brackets in it yet, does it? I need to write it with brackets in. The good news is that once you've got it in this form, you put a bracket around here, the factorised form is x plus 5, x plus 2. If you'd done those 2 and the 5 the other way around, you would have got x plus 2, x plus 5, but it's the same thing. It's fine. So that's your first factorisation of a trinomial. We took this, we had our trinomial in the correct format, we did our table, we wrote the ax squared up the top here, the c part here, we did combinations until we got one where the cross product gave us the bx. Now I'm going to do more examples of that, because obviously that's pretty new. And they get nastier when you start involving negatives. So, let's do this. So factorise. Why don't we do that one? We'll do that one, make sure that we get that. So if I factorise x squared, take away x, take away 12, I draw my grid. I write the ax squared part up here, I write the c part here, and I start my combinations already. So what's going to multiply to give x squared? X and x. What can multiply to give negative 12? This is where you need to be comfortable with your negatives, isn't it? Alright, I mean there's a lot of combinations for 12, so that's a bit annoying. I'm going to get one that's going to be only slightly wrong here deliberately. I'm going to make it 4 and negative 3. Right? Because that, you know, you end up wanting a negative 1 there, so that's probably not going to be far off. So we draw our crisscross. We get negative 3x plus 4x. That gives us 1x, or just x really. Is that correct? Has that given us our b component? No. We actually want a negative 1x, and that's a positive 1x. So we need to try another combination, but it's really close. So you can probably, some of you are probably able to guess right now what it's going to be. X, we put the negative on the 4 instead of the 3. We do the same thing again, crisscross. That's 3x, take away 4x, equals negative x. That works. We've got the b. We've got the b component, right? We've got our negative x there. So that's the solution. So in the end, we put the brackets around it. It's going to be x, well, x take away 4, x plus 3. Which, yes, I could write that way as well, right? It was written as the x plus 3, x take 4. It's the same thing. So there we go. We factorise that horrible looking thing backwards. I'm only going to do one more example before recommending that you go and do your text. There's one particular case I need to show you. And it looks a bit like this. Factorise and this one's going to have something in front of the x squared, but a really easy way of getting around that problem. Let's say 5x squared. There's something interesting I want to include in this one that I also have to think about. Unfortunately, I'm going to have to use my brain briefly for this one. It'll be subtract 25x plus 30, I think. Yeah, that should work. All right. This one is an unusual case where, well, to start with, you've got something in front of the x squared, but that's not the end of the world. What we have here that's weird is you actually have a common factor across the 3 here that you can take out first. So, general advice, do look out for common factors. So there's something that goes into all of those components there. Can you tell what it is? 5, right? 5 goes into everything there. So if you do have a common factor, you can extract that out first. I'm going to put 5 out the front, then a heap of stuff in brackets. So 5 times what gives 5x squared? It'll be x squared. 5 times what gives negative 25x? It'll be negative 5x. And 5 times what gives us 30? That will be positive 6. Right? But once you've done, if you're able to get it to this stage where you've got just the 1x squared again, when you've got just the 1x squared in there, you can now just use your original technique, what we've already done. So what we're going to do is factorise this bit in here, and then we'll bring the 5 back at the end, because we haven't forgotten about the 5. Alright, so from there, our standard factorise, so I'm just going to go look for common factors and note take out first. That becomes your first step, is to factorise. So I'll put a big step 1, and now put a big step 2. Draw up our standard table. We've got our ax squared part is just x squared again. Our c components are positive 6. As is usual, what multiplies together to give x squared? It's just x times x. And then you have to think what multiplies to give 6. Tricky one. Notice how the bx component's negative. How can that possibly be? What can multiply together to give 6 that involves negatives? I'm hoping some of you get the idea that if you have 2 negatives, you can get a positive. It's going to be 2 negatives. So 2 negative numbers to multiply to give 6. Let's try 2 and 3. Negative 2 and negative 3. We do our crisscross. So that's going to be negative 3x plus negative 2x, which is just negative 3x, take away another 2x. So that's going to land at negative 5x, which is actually what we wanted. We got the solution first time off. The more you practice this, the more often you'll find you get that solution first time. All right, so I can then write this. So that part is going to be x take 2, x take 3. At the fully factorised form, we've got to bring our 5 back. Don't forget about our 5. So it's going to be 5, x take away 2, x take away 3. In your text there are more examples, but they're done a slightly different way. You can do it a few different ways depending on what you're comfortable with, but the next lesson I'm going to do is going to again show why this technique is kind of cool. It works in a lot of different situations. And just to rehash on the whole idea, you've done expanding of trinomials before, so you've done situations where you expanded things 2 parts in each bracket. You've expanded them to get a trinomial. Today was all about factorising, about going the other way, about getting your 3 parts here, putting brackets in. All right, so today was factorising, tomorrow a little bit more advanced factorising. If you got any questions, you know where I am, you know who I am. Thank you.